around the same time, Wells, remember the dentist who saw the demonstrator who was under the influence of this nitrous oxide, yeah, and Wells actually then went on using nitrous oxide as a general anesthetic for his practices, for his dentist practices. So Wells has a dentist partner called Dr. Morton, yeah, and Dr. Morton in this case, yeah, was somewhat not convinced of nitrous oxide as a GA, yeah. So he turned to ether, okay. Um, so he actually tried ether on his patients, yeah, for tooth extraction, and that procedure went so well that he managed to maintain anesthesia, yeah, or the degree of unconsciousness in many patients over a minor surgery, yeah, tooth extraction, and so on. So just to show you the structure of ether, this is what Dalton thought of structure of ether, which is now otherwise we don't now we know that ether is comprises of a um, two ethane moiety, yeah, that flank an oxygen. Okay, so ether is usually known as diethyl ether or ethane. Yeah, very characteristic smell. Yeah, is volatile. Yeah, it's the boiling temperature is 34.6 degrees Celsius. And if you actually have a bottle of ether, yeah, you open it, you can see that ether will start coming out slowly from the container. So ether never sits still. Actually, it's just starting coming out slowly on the sides and so on. Yeah. The chemical properties of ether is actually flammable gas and is explosive if it's mixed with air, yeah, or oxygen, pure oxygen, or nitrous oxide. Yeah. However, it is fairly stable chemical, yeah, to acids and alkalis, except to cold hydrogen iodide solution. Okay. So let's have a look at the chemical instability of ether. Yeah. So ether can be auto-oxidized by light. Yeah. And so in this case, if you have ether group here, yeah, this hydrogen can form under light, yeah, under light after a certain period of time, can be actually released as a free radical, leaving a carbon radical in this case. Yeah. So this is a homolytic dissociation of the hydrogen radical. Yeah. And with further contact of oxygen, you see oxygen as well, O2, yeah, it can also form oxygen radicals. Yeah? And on contact with oxygen radicals, the carbon radical will further form peroxide. Yeah? And in this case, you can see that this peroxide can actually, with further contact with ether again, yeah, it can form hydroperoxide and another carbon radical. Yeah. So in the case of these two, yeah, actually the formation of organic peroxide is more favored than the hydroperoxide. Yeah. But let's see what's the consequences of the two peroxides, the hydroperoxides and organic peroxides of ether. Yeah. So the hydroperoxides can further broken down to hydrogen peroxide. You remove the hydrogen peroxide and water, yeah, forming these vinyl ethyl ether, and further removal of water produce an hemiacetal and an aldehyde. Yeah. and also ethanol as well. Okay. On the other hand, this hydroperoxide can further actually form actually with rather than the removal of hydrogen peroxide. So upon removal of water, yeah, it can further be it actually further form. I think this is ketone. Double check of me on this one. On further removal of molecule of water, yeah, it can actually form this acetic acid and also ethanol. Yeah. So if you have a bottle of ether, yeah, and it just remain under light, even in this in the lab environment as well, it remain under light, it's exposed to light. Yeah, you can actually these peroxide formations can happen. Yeah, so to destroy the peroxide, yeah, it is actually advised that the ether should be shaken with sulfuric acid solution of iron to sulfate, yeah, or even leave it to stand in potassium hydroxide. Yeah. So due to, if you see here as well, due to so ether is never been in a form of pure ether because of this outer oxidation of peroxide of ether under light. Yeah. So ether would have some ethanol in there, could also have a little bit of acetic acid, and also here can also form ethanol as well in here. So for centuries, ether has been used. People actually drink ether because they know they can actually get drunk on that, in a sense.